Okay, so we have 11.2, question 25, and in this question we've been given a fixed point 3, 2, which is labelled as R, and then we also have a movable point P, and we're finding the equation of the locus of P if the distance PR is twice the distance from P to the line y equals -1. So we got y equals -1 down here, and we've got a moving point P, and the distance from P to R is twice the distance from this kind of what looks like a directrix but won't be. So if we put point P here somewhere, and that distance there, PR is 2 times the distance from P down to the line. Now, of course, it's not very well represented, but I didn't want to put it right on the axis to make it think that that was important. Now, it has to be equidistant for it to be a parabola, which most likely means that we've got an elliptical shape going on here, not a parabola. And so let's have a look. We've got the distance PR being, if P is x comma y, we've got x minus 3 squared plus y minus 2 squared, all square rooted for that distance. So that's the distance from PR, and the distance from P to the line y equals -1 is always just the distance between the y values, and so that distance should just be always the distance from P to the line is equal to y minus -1, which is +1, whatever the difference between the y values is, because that's going to be the shortest distance every time to the line from wherever P is. There's no difference between the x values, only a change in the y values. Now, we know that the distance of PR is twice the distance of P to the line, so we get x minus 3 all squared plus y minus 2 all squared square rooted is equal to twice the distance from the line, so that's 2 outside of y plus 1. And then in order to solve this, we need to square both sides to undo the square root. So we get x minus 3 squared plus y minus 2 squared is equal to 4 outside of y plus 1 all squared. So that's squaring the left hand side and the right hand side. And then from here we just need to expand and simplify. And we're not going to get a lot of cancellation. We will get some, I think. Let's have a look. So we get x squared minus 6x plus 9 plus y squared minus 4y plus 4. And over here that's equal to 4y squared plus 2y plus 1. As you can see, it doesn't, cancel neatly and nicely, so I'm just going to move everything across to one side, and I get x squared minus 6x plus 9 minus 3y squared minus 6y plus 3. And of course you can clean up the numbers if you like, it makes no difference really, but x squared minus 6x minus 3y squared minus 6y plus 12 equals 0 would be probably the best answer for that. Okay, now just amending that because I realised I didn't actually multiply out by 4 correctly. In the third line up from the bottom it should actually be 8y here because I forgot to times by 4, and it should also be plus 4 there at the end, and so in the second line that makes this now, instead of minus 6y, it makes minus 12y. In addition to that, you've got 4, take away 4, so there's no plus 3 here. And on the last line, you're also you've got 9 plus 9 now instead of plus 12. So that's also minus 12. So just an incorrect expansion of timesing out 4 onto the right hand side. And so the amended solution should now actually read x squared minus 6x minus 3y squared minus 12y plus 9 equals 0.